Okay, we continue. Okay, before we begin our experimental work, so make sure that we we connect our power supply, which is from this particular building. I want to ask you, what is the type of this switch? So please give some explanation regarding on these types of switch. And this one, what is this? Okay, and what should be the rated voltage for this one, this building? I want you to think what should be the voltage, the rated voltage for the building. Okay, please think about this, and soon I will ask in our lab session. All right, so as you can see here, from this blah blah blah, then it goes to our terminal block over there, you see, and from there it distributed to all stuff, to all instrumentation of Lucas Neuler. Now I would like to show something from here. Why it's so tough? Okay, you see, here we have 5 pins, and there is one biggest compared to 5 terminal. So what is the biggest electrodes there? I mean, here we have 5 electrodes, right? Then we have biggest electrodes there. So what is the difference between the biggest and those 4 electrodes? So please give some explanation regarding on this. And what should be the rated voltage that carrying by these cables? So please think about this. Right now, and then what is next? It goes to this instrument. Now we come to this instrument, right? So this is our power supply. So this is the code number, and also under Lucas Neuler product. Okay. Now, as you can see here, so there we have indication for current meter, and we have indication for voltage meter, and here we have breaker, this one. So if anything happens, say there is an interruption or there is a fault, so this will take over. Say if we have inrush current or inrush over voltage, then this will take over. I mean, it will automatically switch off. Then here we have knobs for permanent line 3, line 1, and also it can be for supplying DC with the rated with varying voltage from 0 to 230 volts DC. Okay, so this is the limit of the current, so it cannot exceed 2 amps. Yeah? And then here we have selector, right? As you can see here, we can have, this is from lines to neutral. Just forget about DC for a while, but of course it can be also for DC by activating the cables with the connection. Then you can have DC if you set at this particular selector. Now at the same time, it can be also for line to neutral. Okay, then you can have line to neutral as well, line 2 to neutral, line 3 to neutral. And what about this one? Now I want you to explain what is the difference between this selection and this selection. So please think about this. Okay, then we have an indication L1, L2 and L3 over there, right? And this is the knob. So the features of this knob is to provide variation of voltage, okay, where you can have the voltage from 0 to 400 something, 450, or it can be from 0 to 255 volts. Then again, this question come where basically this is some hints, okay, regarding on this question. Just now I asked you what is the difference between this selection and this selection, and nicely with this stuff we can see that at this particular selection is related to here from 0 to 255 volts. Okay, on the other hand, this side, right side, is related to this one 450, where it can change from 0 to 450 volts. 2 amps is the limitation. This is a maximum. So think about that, right? Here's the okay, this is a safety instruction. Wait, you can't. Anyhow, this is safety instruction. Okay, okay, over there you can see safety instruction, right? And then it's good to read this one. I will try to share with all of you regarding on this tab, safety instruction. So it's good every time when we start our session. It's good to read. Yeah. So for instance, it tells about what should be the precaution that has to be taken into account. So for example, here it's mentioned, in all experiments using mains voltage, high life-threatening voltage rise. For that reason, use only safety measurement lead and make sure that there are no short circuits. Okay, so in this particular instruction, it asks you to make sure you use a proper cables. Okay, basically this is so-called banana to banana. Okay, banana, this is a banana connector, banana to banana connector. Alright, there you can have shorter, medium, and the longest one. Yeah, as you can see like that. Right? Alright, now it is imperative that all the devices which are provided with an earth or where earthing is possible must be added. This is particularly the case for the frequency converter being used. So whatever case, every time when you deal with electrical connection, then make sure that all the grounding stuff has to be grounded in a proper manner. Otherwise, it will cause dangerous to everyone. And for instance, here we have grounding stuff. So say after you do have you have completed all the connection, then ensure that each point, any grounding point must be connected to your power supply. Because in this particular case here, as you can see here, this is a connector. So it's related to the grounding lines. Okay. Yep. And goes to our main building. Anyhow, I will share with all of you, so you can please have a read this one, this particular instruction. Yeah. Okay, next. This is our main job. Okay, for this week. Welcome to the energy management course from Lucas Nuller. The team from Lucas Nuller would like to wish a lot of fun working through the course material and in conducting the experiments. The following pages provide an overview of the course content and the required equipment. The objective of this experiment is to investigate and demonstrate the theoretical aspect of the operating response of linear time invariant complex load in an AC and three-phase power system and the associated current and voltage relationship. So this is the main main idea for working in this particular experiment. Yeah, basically we would like to realize from a theoretical aspect and try to see the response, respond by monitoring using this stuff. Of course you have to complete all the connection, either more inductive, more capacitive, and then we would like to see the response from here. That's the idea. Then using phasor diagram of a time variable, harmonic variable, blah blah blah, like that. Measurements are conducted for the purpose of investigated load of resistive. You see, this is what I explained to all of you. This one. Measurement are conducted for the purpose of investigating loads of resistive, inductive, and capacitive kind within the three-phase system, both in star configuration as well as delta loads. These measurements are in turn put to test by comparison with calculation. Right? I will share with all of you anyhow. So for the timing, we will only focus on try to get familiar in this week. Basically, I would like all of you to get familiar with this. The most important stuff is, of course, nothing but from our main power supply and few number stuff here, right? Especially just one, and then the basic loads. That's all for today. Thank you very much.